Okay, we're looking at mathematics of finance. There's a guy called William in question 3.1. Right, William opened a savings account with 10,000 Rand. 2 years later, he deposited a further 4,000. So in other words, in 3.1, we have a timeline like this. In which case, we have time 0. William opened a savings account with 10,000. 2 years later, a further 4,000. And 5 years after the account was opened, 2 years later, he deposited a further 4,000 Rand. So, in other words, you opened a savings account with 10,000 Rand at time 0. There's time 1, there's time 2, there's time 3. Okay. 2 years later, he deposited a further 4,000. So, in other words, so this time 0, and then here is the first year, and then the second year. And then now after that, he deposits a further 4,000 Rand. 4,000 Rand here. Okay. Right. So 2 years later, he deposited a further 4,000 Rand, and 5 years after which the account was opened. So, right. So you have that there. 2 years later, 4,000 was deposited, and 5 years after the account was opened. Right. So he deposited another 3,000. Right. So this is very interesting. Right. If the interest was calculated at 8.6%, right. So you're dealing with an interest of 8.6% annually. Calculate how much money he had in his savings account at the end of 8 years. Right. So in other words, we shall go up to 8 years. And we want to know the amount of money he's going to have here. That is so much in the future. All right. So we are looking at exactly this scenario here. The interest rate is actually 8.6%. Okay. So this is exactly what you have here. Right. So obviously, we need to sit down and think very carefully and make sure we understand the story. We need to understand exactly how this timeline works, but also we need to have a fair understanding of what is happening with this situation here. Okay, so there are a couple of ways, obviously, in which we can analyze this question, but our interest is actually in understanding precisely how much money he had in his savings account at the end of 8 years. So once again, I want us to read the statement once more for the second time and make sure that we carefully understand what's happening. Because we're dealing with William, and he opened a savings account with 10,000 Rand. So, in other words, he actually opened this with 10,000 Rand. 2 years later, he deposited a further 4,000 Rand, right? And 5 years after the account was opened, he deposited another 3,000 Rand. So you have this one before. Okay, let's remove this one. P5 here. Right. Okay, I need to get my pen tool. Can I please get my pen tool? Just a sec. Right, I need to get my pen tool so that I can be able to write clearly. Okay, so you have this one here. Right, let me get my pen tool so that you can write very clearly. All right, so you have T5, T6, then you have pi 7, which is in years. Right, so and 5 years after the account was opened, he deposited another 3,000. Another 3,000 like that. 5 years after the account was opened, he deposited another 3,000. If the interest rate was calculated at 8.6% annually, in other words, per annum, calculate how much money he had in his savings account at the end of 8 years. Let's look at these together and try to actually make sense of this situation. Right, and try to make sense of this situation. So now this can be done in a couple of stages. So if you want to find out how much money he had in his account, we can do things like this. We can do things like this. We can do it like this and say in 3.1, so in 3.1, right, so obviously we want to find exactly the amount at the end of 8 years, so we're interested sort of in finding the total. So we're going to use the formula because there's growth. We're going to use the formula of this one here. And so we're going to start by saying the 10,000 Rand that was actually used to open the account, 1 plus the interest rate of actually 8, so you have this 8.6%, but you can write it as the following as 0.086, right? You raise it to the power. So it was in the first 2 years, this 10,000. Right. So simultaneously at this time, he adds another 4,000. Right. He adds another 4,000. After he has added another 4,000, everything goes together for the next 3 years from to T5 for the next 3 years. So you have 1 plus, use this formula again, 0.086 for up to the 3 years, because 5 minus 2, T5 minus T2 is going to give you 3. So you have 3 years, right? So in the 3 years, then you have that he deposits another amount of money. So the question becomes, how much will this 10,000 plus the 4,000 with interest become at time T5, right? So if you do use a calculator, you get 20,229 Rand, 28, 28391. Right, so that is what he's going to have in the account at time at T5, but now he decides to perform another deposit. He performs another deposit. He takes this money here. So there is this 20,000. 20,229.28391. 391. Okay, another amount of money is added to that, which is at T5, it deposits another 3,000, which therefore increases the amount of money in the account. But the 3,000 finds money in the account, and now it stays there. When then it must be subjected to interest for a further number of years from T5 to T8. 8 minus 5 is what? Is exactly 3. So in other words, that was going to be 1 plus 0, 0.086. 3 years. And if you do this, actually, it means that it's going to have in the account 29,752,63. So he's going to have in the account this amount of money, 29,000. 29,000. Okay, so that is the answer, and we are done with that question. So there it is. This is the final answer to the question. Right, so we are good. Right, the next question is about Sente. Sente wants to buy a new laptop that costs 9,000 Rand. He pays a 15% deposit and uses a higher purchase loan for the balance. Calculate his monthly payments if the loan is for 2 years at an annual interest rate of 14%. Okay. So we are here. We are here. Okay, let's look at the story of Sente. The story of Sente is that Sente wants to buy a laptop, a new laptop, that costs 9,000. He pays 15% deposit. Okay, so if Sente pays 15% deposit, we understand that there's going to be exactly 9,000 less 15%. So there's going to be 9,000 less 15%. What is the answer? 7,650. So you subtract 15%, 9,000 less, because now he pays a deposit of 15%. And that means that is 9,000 less 15%. And uses a higher purchase loan for the balance. Okay, uses a higher purchase loan for the balance. So in other words, he takes a higher purchase loan for the balance of 7,650. Right. So obviously, understand that this higher purchase loan is actually subjected to right. I want to say now, calculate his monthly payments if the loan, okay, if the loan is for 2 years at an annual interest rate of this. Right, obviously, because we're dealing with a higher purchase. So the higher purchase now is actually this one here. It's simple interest. Right, so those are the things you're gonna see, the simple interest. So if you have the simple interest, what do we do with the simple interest? Right, so now we underline this one here. Okay, for the 3.2 part, this one, we're gonna have the following. Right, so we're gonna use the formula A equals P into 1 plus IN. Okay, which is the simple interest, this one here. Right, this one is simple interest for Sente. But now remember that therefore the loan He's going to take the loan for the amount of the balance, right? So the one that is must be paid there after the 9,000 less 15%, which is 7,650 into 1 plus. The interest rate is actually 14%, which is 0.14 because it's 14%, multiplied by n, which is the number of the years, and it's 2 years at 14%. So 2 years. Right, use this because the higher purchase is simple interest. So use the formula, you don't put the power, you just put IN like that. So as a consequence, what we're getting is actually that takes a loan of 7,650 is going to pay back 9,000. It's going to pay back more, 9,792. That's what it's going to pay, 9,792. Okay, 9,792 monthly. How much is he going to pay? Because calculate his monthly payments. Right. So in other words, the monthly payments. Right. What are the monthly payments? So the monthly payments, therefore, are going to be the 9,792. You divide by 24 for the 2 years because it's 24 months. And therefore, it's 408 monthly. So it's going to pay that amount of money, 408 monthly. Okay, so that is what we obtained there. That's what we get. Next question. So obviously in this question, you need to understand two things. Right. So we have this answer. Okay, now let's look at, so obviously in 3.2, look at what they're asking. They said calculate the monthly repayments if the loan is for 2 years at an annual interest rate of 14%. So in other words, we need to calculate the monthly payments. The monthly payments will therefore become these. You can even call them monthly repayments there. Okay, right. In 3.3, a business buys machinery for 2.2 million. Okay, so in a business, they buy machinery for 2.2 million. Depreciation is calculated at 17.5% per annum, calculated on a reducing balance. Okay, so 3.3.1. Right. Calculate the book value of the machinery after 4 years. Okay, how to calculate the book value? You need to understand that it's actually on the reducing balance. So on the reducing balance, you use the formula A equals P into 1 plus I, 1 minus, because it's a reducing balance. Okay, so you're going to use the formula with the minus. So it's 1 minus I to the power n. So this is 2.2 million. So 2.2 million is like 2,200,000. That's 2.2 million. Right. And then it is into 1 minus, because it's the reducing balance. So there's reduction. So you have a minus. Right now, the 17.5%, you divide by 100 this. You divide by 100 is 0.175 raised to the power. Right. So obviously the book value of the machinery after 4 years. So you put the fourth power. Right. So if you put the fourth power, what does this become? Right. You can write at the bottom here to create a little bit of space. What is the book value of the machinery after 4 years? So in other words, this machinery is actually getting old. So how much will it be worth? That's the book value. How much will it be worth? Okay. Right. So it will be worth 1 million. 0.19150, comma 86. Gonna be worth this much. So in other words, you buy this machinery for 2.2 million after 4 years is just worth just above 1 million. Okay. So this is exactly the amount of the money that the machinery will be worth in 4 years. So in 4 years, it would have undergone depreciation. Right, right, we continue. So now, if you look at 3.3.2, calculate what it will cost to replace the machinery after 4 years at an expected inflation rate. Okay, there's inflation. There's inflation. Okay, there's inflation. So now that one I'm giving you 2 minutes to do 3.3.2, then we shall do it together. Okay. Okay, you need to have your book. I did not say. So you need to have your book with you so that you can write the things down, because in the end, right, so we are good. We are so good. Right. Okay, Senula is here. Right, so we're looking at 3.3.2 right now. Right, I just invited Senula to join us with Likuku on the line. Right, so we are trying to look at this question and we are looking at the answer to 3.3.2. We need to calculate what it will cost to replace the machinery after 4 years at an expected inflation rate of 6.5% per annum. Write your answer to the nearest rand. Right, so I'm just giving you this and I'm expecting you to try the question and tell us what we get. Okay, and tell us what we get. So we have this. We have this. So tell me, please. Okay. Right. Yeah, 3.3.2, you need to calculate what it will cost to replace the machinery after 4 years. So we are saying now, how much will it cost to replace the machinery after 4 years, and an expected inflation rate of that. So in other words, at that expected inflation, how much will a new machine cost? And that is the question we're asking. How much will a new machine cost? Right, in this case. So obviously, at this point, okay, let's see. Okay, let's just check. There, Ligugu, right. Okay, might have got the answer. Okay, that's fine. Let's take a look at the answer, Ligugu. No worries. So, this is what you're gonna do. Right. So, you actually have this. All right. We have exactly these here. Zenolo, you're here, right?
Yes, sir.
All right. Okay, we're just doing this finance. The reason why I'm focusing a lot on finance is because this other student is writing a test on Tuesday on finance. So I'm trying to make sure that the student is prepared, you know? That's the reason why I'm focusing more on finance. I'm trying to make sure that at least the student is aware of the kinds of things that finance is about. Right. So obviously simultaneously you also need to master this finance as well. So it's not a train smash. All right. If you look at 332, 3.3.2, calculate what it will cost to replace the machinery after 4 years as an expected inflation of this. So the inflation is 6.5% per annum. Write the answer to the nearest rand. Okay, so how much it will cost to replace the machinery? Okay, we're in the middle of the calculations and we might not be able to follow, but I was recording the video from the beginning. So we're going to use the formula because it is subject to inflation. We use compound interest. Unlike the hire purchase agreement, we said the hire purchase agreement uses the notion of simple interest, but this one, which is inflation, is subject to compound interest, and we use this formula A equals P into 1 plus I to the power n. Right, so we have 2.2 million because this business buys machinery for 2.2 million. So it is 2,200,000. That is the cost of the machine. 1 plus. Right. What is the inflation? It is 6.5% per annum. So 6.5% per annum means you divide the 6.5% per annum because it's compounded annually. So dividing by 100, the 6.5 gives us 0.065 raised to the power. How many years will those be? They're exactly 4 years of inflation. Right, 4 years at an expected inflation rate of this much. So, right, it's 4 years, and then we get the answer. Right, if you look at this here, it's 2.2 million. So if you use a calculator, it will actually become 2,830,226. So this is what the new machine is going to be worth because they're saying calculate how much it will cost to replace the machinery after 4 years. We need to first look at, if somebody asks me to say how much will this loaf of bread be worth in 4 years' time, we need to ask what is inflation, because inflation is what is going to push the prices up. So it was 2.2 million this machinery, but subject to an inflation rate of 6.5%, it's going to become 2.8 million. Okay, which is 2,830,226 rand. So that is how much the machine will cost in 4 years. We are recording this discussion there, Tsenula. So yeah, you'll have a chance to see. So obviously we're able to see what answer you can be able to compare their Ligugu, so that you can be able to see for yourself the questions. Okay, now we have more finance for Ligugu because I know that she's actually obviously supposed to be um, very sharp in finance. So we are looking at inflation, which is a compound interest phenomenon. We are looking at a higher purchase agreement, which is obviously a simple interest phenomenon. Now, in 4.1, we are looking at 8,000 is invested for 5 years and an interest rate of 17% per annum is compounded monthly. Determine the value of the investment at the end of 5 years using the nominal interest rate given. Okay, so here we're dealing with the nominal interest rate. How do we calculate investments? Because it is an investment using the nominal interest rate. How do we do this question? Okay, it's very obvious because if they say the nominal interest rate, you're going to use the formula A equals P into 1 plus, okay, 1 plus exactly the I divided by M raised to the power N, then M. Right. So this is A equals how much is in being invested? It is 8,000. So 8,000 is in the present into 1 plus. What is the interest rate? It is 0.17 divided by. Right. So what is the M? Right. In this case, it's compounded monthly. How many times per year? It's 12. 12 months in a year is raised to the number of the years. How many are they, the years? The years are exactly 5 times 12. We use our calculator and we're able to get exactly what the 8,000 is going to become, which is invested. So this is what it will most certainly become, this 8,000 after investment. So it becomes the following. Just a quick, let me just remove this. Let me just remove this. So it becomes exactly this. Okay, goodness me, we are doing well. 18,605, comma 87. So in other words, we have 18,605,87. So in other words, 8,000 is going to become 8,605,87. This is what is going to be worth in 5 years time. Okay, convert the nominal interest rate to an effective interest rate. So as part of our finance learning, we must be able to convert the nominal interest rate to the effective interest rate. How do we convert that one? So we use a formula. What formula do we use? Okay, what formula do we use? We use this formula here. We use this formula because we must be able to convert the nominal interest rate to the effective interest rate. How do we do that one? Right, so we need to master mathematics of finance or financial mathematics. All right, so we're good. We're good. So we have 1 plus. 1 plus R effective is 1 plus I nominal divided by M to the power M. So this connects effective interest with the nominal interest. So if we want to get effective interest, it means that effective interest is actually 1 plus the nominal interest divided by M to the power M minus 1. So which means we need to do the calculation here of the effective interest. Right, so what do we get this one? So we have the nominal interest rate. So this therefore becomes exactly what we get. because they're saying convert the nominal interest rate to the effective interest rate. Right, so you have 1 plus, what is the nominal interest rate? It is a 17, right? So you have the 17 monthly there. So you have the 0.17. You divide it exactly by 12. You raise everything to the power 12 minus 1. And therefore, you get the answer. Right, so let's do this calculation, please. Let's do the calculation, please. So do the calculation is 1 plus 0.17, 12 to the power 12 minus 1. Right, if you do this one carefully, what you're getting here is 0.18389. So you can then write this one as you multiply by 100 times 3, multiply by 100%. So you have this. You have this. 18,389. So this is the answer to the question. 18,389%. Okay, so that's the answer. Right, so this is the answer to the 4.1.2 part where we had to convert the nominal interest rate to an effective interest rate. Right, so if you have to convert the nominal interest rate to an effective interest rate, then the nominal interest rate is 18,389%. Right, so if you look at the 4.1.3, use the effective interest rate to calculate the value of the investment, comment on your solution, and that in 4.1.1. Okay. You need to use the effective interest rate. Okay, so use the effective interest which you just got. We got the effective interest, which is 18,389, to calculate the value of the investment. Okay, let's find the value of this investment. What is the value of this investment? So in other words, the effective interest rate is the annual rate. So for the annual rate now in 4.1.3, we're going to use the formula A equals P into 1 plus I to the power N. What is the present value that is being invested? They're investing exactly 8,000 into 1 plus. What is the effective interest rate? Right, we've already got it. You can put the 18%, but we put the decimal after division by 100, which is 0.18389. It is raised to the power N. Right, so the power N is what? Right, so obviously we need to understand everything is done in 5 years because this 8,000 is invested for 5 years. So if you use a calculator here, you'll be able to get the value of the investment using the effective interest rate as exactly 18,605 Rand and 88 cents. So the question is, what is the difference between these two amounts of money? Here we use the nominal rate, which was the monthly rate. Here we use the effective rate, which is the annual rate per annum. Now here we got this one, so we need to compare these two results, this one and that one. How do they differ? It's just 88 and 87, just the rounding off there. But obviously the two solutions are similar. So in essence, you can use any of the rates for the two solutions. Right, so the two solutions are similar.
Sir,
Yes, please.
me for finance, I'm good, so I'm gonna go now.
Okay, that's fine because I'm trying to get these students. So, yeah, please expect me when I'm free in the evening to check on you. Okay,
Okay.
that's fine. Yeah, because I'm just trying to get this student boosted on finance because he's writing finance on Tuesday. So yeah, that's why.
Okay, sharp, sir.
When I'm done, then I'm gonna finish at about 8. I'll then see what time I can contact you, but I'm gonna finish at about 8 tonight. This discussion on finance. Okay.
Yeah, you'll tell me then, sir.
Yeah, I'll let you know. Okay. Okay, goodbye, Tenu. That's fine. Right. So let's continue right now and we look at Zakele. So we're looking at now question 4.2. Zakele inherits 10,000 Rand and invests it in an account for 8 years. If the interest rate for the 8 years is 8.4% per annum, but is compounded half yearly. So the 8.4% compounded half yearly, because it's not compounded annually, it is actually what we call the nominal rate, and then rises to 9.2% per annum. So there's a change in the rate compounded monthly for the remainder of the investment. Calculate how much interest he has accrued on his inheritance. Let me give you 3 minutes to do 4.2 about Zakele, and then we'll do the corrections. Give you 3 minutes because I'm trying to train your mind. Because if I never give you an exercise during the discussion. So I give my exercises during the discussion. I don't give at the end because I want to make sure that at least during discussion you follow. Need to make sure that you follow. Okay. 4.2 is what we're doing right now. Okay, please let me know when you're done. Please let me know when you're done. Okay. Right. So Zakele actually is one guy who is very fortunate and therefore he inherits some money. So when he inherits the money, he's able to invest it. So let's look at 7.3. Zakele inherits 10,000 and invested in an account for 8 years. If the interest, so you see, the minute they mention some years, it helps to draw a timeline like this. And then you write on time zero here at the beginning. So Zakele inherits 10,000 rand. So the 10,000 rand is there at the beginning. And invested in an account for 8 years. If the interest is that, so in other words, this is up to 8 years. If the interest rate is for the first 4 years is that compounded half yearly, and then it rises to that compounded monthly. For the remainder of the investment, calculate how much. So if it's the interest rate for the first 4 years is this, which is compounded half yearly, right? For 4 years, how many half years are there? So you're gonna go up to time 8. So in other words, here you're dealing with the half years, yeah. And then now, and then rises to, and obviously this is 8.4% per annum. And then rises to 9.2% per annum compounded monthly. So here we are dealing with the monthly rate. Okay. Right, so let's deal with the Cyril Zakele. Right, so in other words, for the first 4 years, there's going to be 8.4% compounded half yearly, and then rises to 9.2%. Okay. Okay, so the interest rate for the first 4 years is 8.4% compounded half yearly, and then rises to 9.2% monthly for the remainder of the investment. So monthly, therefore, is going to become you're right, for the remainder of the investment now it's that. So okay, right, and then rises to 9.2% compounded monthly. So for the next 4 years, how many months are going to be there? They're going to be, so you have 4 by 12, which is 48 months. So 48 months, right? So obviously now you have 48 here. So if it's 8 here, so you need 48 more of this. So how much are you gonna have here? All right. So obviously you get to add to this, and you add 48 more to this, and that is gonna give you a total of 56. Right. So you have T9 and so on, T10 and so on, and then you have T55 here. Um. Okay, we continue. We continue. Right, so you have T8 like that. So Zakiri now inherits 10,000 and invested in an account for 8 years, and the interest rate is that. Okay, right. I'm giving you 2 more minutes to have analyzed it. Now it's pretty obvious, and we can just do it easily from here. Right. So tell me what answer you get in the question of Zakele. We're gonna finish it now together. I want to see what you think about it. I always want to make sure I engage your ideas, because if I engage your ideas, we actually will make significant progress. We'll make significant progress. So we have these. Right. We have this. Let me know when you're done. Okay, because I'm here. I just want to see what you're going to do here in as far as doing this is concerned. All right. So you let me know how far. You let me know how far. Let me know how far. Okay. Let me know how far. Um, you let me know how far. Okay. Right. So, right. Are you able to make sense of the question? Are you able to get the answer to the question? So those are the kinds of things we are looking at there. So the kinds of things we're most certainly looking at there. Okay. Right, 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 right. Okay.
Sir,
Yes, please.
I got 12.67.
Okay, what did you get?
12.67.
Did you get 4 point?
12. 12.
Okay, can you type it on the thing on the charts so that I can be sure. Greetings. Fine, thanks, and you? Yes, that's fine. Ah, is it? At what time? It's due at 8 o'clock, eh? And the time is what now? It's 7:04. Can you confirm the due time, please, again? Oh, 100% sure it's 8 o'clock today. Can you just cross-check like a million times so that you can be like cocksure? Because maybe it can be 11 or 10. And then we can plan better for it. Yeah, just like cross-check, please, so that you can be like sure, so that you don't just rush it. At 8 p.m. exactly. All right. Let me get back to you then so that we can sort it out. Okay. Yeah, ASAP, very soon. Very soon I'll get back to you just now so that you can sort it out. Okay. Okay, thanks. Goodbye. Right, so you have this here. Okay, so we're gonna check your answer, please. Okay, in the charts I can see 0.67, but let's just check together. So obviously here in the 4.2 part, I was saying 10,000 is invested. Zakari inherits 10,000 invested in account for 8 years. If the interest rate for the first 4 years is 8.4% compounded half yearly, and then rises to 9.2% compounded monthly, for the remainder of the investment, calculate how much interest he has accrued for his inheritance. We're using the formula A equals P into 1 plus I to the power n. So that in the 4.2 part, you're dealing with 10,000. And then I'm trying to check your answer because obviously you got the answer, but yeah, I'm trying to verify if you're going to get the same answer or not. Okay, because the 10,000 is invested, you're going to use the formula with actually 1 plus I to the power n. So it's 10,000 that is being invested. Then the interest rate is 8.4%. But here you actually divide by 100. So if you divide 8.4 by 100, you get 0.084. But it's half yearly, so you divide by exactly 2. Okay. So it is actually obviously for 8 years. If the interest rate is for 4 years, compounded half yearly, so in other words, is for 4 years times 2. Because half yearly means twice a year. And then you have 4 years times 2, right? And then rises to 9.2% per annum compounded monthly. So there is a rise to 9.2%. So you divide the 1 by 100, which is 0.092. You divide by 12. And then it is raised to the power. Because it's monthly, the years are 4 times 12 months. So alternatively, this can be seen as exactly 10,000 into 1 plus 0.084. You divide by 2 half yearly 2 times a year. Okay, 4 times 2 is, you can raise it to the power 8 here, which is 1 plus 0.092. You divide it by 12, raised to the power 4 by a at 12. What is 4 by 12, which is 48? Using a calculator, you're able to see that this is going to be exactly 20,000. 051, 76. So in other words, what we're having is that Zakele calculate how much interest he has accrued on his inheritance, right? So we need the interest. So this is not the interest. How do you calculate the interest? So you get to get the interest. This is the formula we use for the interest. How do you calculate the interest? So we are finding the interest and how do we calculate the interest and? So in other words, here the interest and is the same as the amount here. So it is exactly 20,000. 051,76. You minus 10,000. So which is exactly 10,051, 76. So obviously it means therefore the interest end is 10,000 that. So you take the final amount and you subtract the principal. So the interest end is always A minus P. And you get the answer. So if they ask you in the test, in the exam, to calculate the interest earned, what is the formula? It's A minus P, and you get the answer. Let's look at the question about Sipo. Sipo is a good guy. Sipo invested 15,000 in a banking account. After 5 years, he withdraws 28,000. Calculate the interest rate rounded to 2 decimal places per annum if it was compounded half yearly. Okay, let me give you 4.3 about Sipo because he invests 15,000 and then he withdraws 28,000 in 5 years. What is the interest and here there? Do 4.3. I'm giving you like 2 minutes and then we shall do the corrections, please. Okay. So this is what we have. Okay. Right. Okay, let me see what you got. Okay, you got 9,33 and reattempt got, okay, that's fine. That's okay. So with me, I'm just interested in checking the answer, so you're going to do it together, then do corrections, because this helps you to learn. Because if you don't try in the class, then you'll just see the answers of the teacher and then say, okay, the answer is 20 and I don't know why, you know. So let's just do this properly here. Right. So after 60 vested, after 5 years withdraws. So this one is not a lot of things that are happening. So, but it is an investment. So we're going to use the formula A equals P into 1 plus I to the power N. So Sipo invested the 15,000 rand. So in other words, so he invests 15,000. Right. So after 5 years, he withdraws 28,000. Right. And then okay. Um, right. So obviously at this point, you have A equals P into this. And then now it is actually, you need to calculate the interest rates, but now it is compounded half yearly. So if it's compounded half yearly, you can just do this and say it's 2 times a year, but it's 5 years times 2. So use the formula A equals P into 1 plus I over M raised to the power M and M or MN, doesn't matter. Obviously, multiplication is commutative, so you can, yeah, but it's popular to write like this. That is a formula we're using. So this one is for the effective rate, this one is for the nominal rate, but here we're using, so this one is the nominal rate formula. And this one is for the effective rate. So when you get this, therefore, is 28,000. Which is 1 plus I over 2. Ten here. So which means here you're going to have the 10th root of 28,000 divided by 15,000. 1 plus ten, 1 plus I over 2, 10. So what you're getting here is that you have the 10th root of 28,000 1 plus I over 2. So which means you have 2 into 28,000 divided by 15,000 minus 1 equals I. So if you use a calculator right now to get the actual rate I, right, you'll get exactly need to use a calculator to get this one. to be sure of what the answer is here. So you have double. You have 2 into. Oh yes. 10. 28. You have 15. Right, so this one therefore becomes 0,12880. And then you multiply it by like 100, this, and therefore becomes 12,88%. Okay, you have 12,88%. Right. 12,88%. So this is the answer. Right, so it's okay. Remember, we're practicing, so we're very close because you got like 12,67. So you're very close. Very close. Next question. Okay, let's look at this one. We can minimize this. Right. Let's look at this car in question 8. The car is worth 140,000 now. If it depreciates at a rate of 14% on a straight line depreciation, calculate the value of the car after 4 years. So let's do this one now. Can I give you like 2 minutes? You do it and then give me the answer, please, because like we've done a lot of the finance, but I'm going to bring like another set of problems like these so that you can right. Okay, can I give you these ones as a homework?
No problem, sir.
Yeah, I'm thinking of giving you these ones as a homework. I'm going to upload the video. There's another student who just asked me that they have a project that is due at 8 p.m. So they are stuck and they need some ideas, okay?
Okay, sir.
So I just think that I wanted to run from 6 to 8, but I feel that that other student's project is going to be it's not going to be possible for the student to have it completed before 8 because now it's like 22 past 7. So I'm
Okay,
giving you
sir.
these
I
problems.
understand.
Yeah, I'm giving you these problems as a homework. You can see them. I'm going to post the video. They're going to be on the video, and then you can watch the rest of the other things and then get to these once here and then try them. In my next meeting, I'm going to start from these and look at other questions as well. Okay.
Okay, sir. Thanks.
Okay, thanks, then. I might be able to see you tomorrow sometime, but you let me know. You let me know. I'll hear from you at the time because you're going to school, right?
Yes, sir.
All right. Yeah, we'll talk then. Okay, thanks. Goodbye.
Okay. Thank you. Bye.
Goodbye.